Hello and welcome to this tutorial. Today I would like to talk about AWS EFS. So let's get started. First of all, I would like to describe what is EFS. EFS stands for Amazon Elastic File System. Basically, it's a simple scalable file storage for EC2 instances. We are familiar with EC2 instances. There are virtual machines inside the Amazon ecosystem, and basically EFS is a kind of storage that you can attach to your EC2 instances and you can leverage it for whatever services or application you're using. EFS is not supported on all the regions, so this is one thing to consider. And the storage capacity is elastic, growing and shrinking automatically, so we shouldn't be really concerned about the capacity. And it is going to use Network File System NFS version 4 or 4.1. If you are familiar with the storages and NAS systems and NFS mounts and Linux systems, this is the same idea as having a NAS storage and Linux mount points. So it's going to use NFS mounts, and multiple EC2 instances can access EFS at the same time, which is exactly like having an NFS volume with a storage and multiple servers can access it. You just pay only for the storage used by your file system, and there are two storage classes for EFS. It's a standard and infrequent access. The prices are different. There's a lifecycle management that you can define to move the data from the standard tier to the infrequent access one. Also, we have encryption at rest, which is like having encryption on the disks for security purposes. In terms of the performance, so EFS file systems are distributed across a number of storage systems. It's elastic and you can grow it to petabyte scale, and it allows massive parallel access from EC2 instances. Multi-threaded applications can drive substantial IOPS, which is IO per second to it. You can use it for big data analytics and other examples. One thing to consider is that EFS is distributed across multiple availability zones. So we have high availability and we have durability. You may say, what is the difference between EFS and EBS? If you remember, when we were creating the EC2 instances, we actually created EBS volumes for them, and we use them for boot volumes, for example. So there is a very good comparison here in terms of the EFS and EBS volumes. So both, they are actually, in terms of the latency, they are good. They are low latency and they are consistent latency. But if you compare, you can see that EBS, it acts a little bit better. So it has lowest latency. But the throughput on the EFS is plus 10 gigabyte per second, but this one is up to 2 gigabyte per second. So the throughput is much higher in EFS, and that's expected. When you have higher throughput, then you will have a slightly higher latency, which is a trade-off here. Another thing that I want to compare here is the EFS versus EBS, and their comparison is really good, and it's actually good for the exam. So the EFS file system is stored redundantly across multiple availability zones, but EBS volumes are redundant but in a single AZ. And I'm going to show you just right now. If I go back to the AWS console, here I'm in AWS console. When you're creating EC2 instances, probably you can remember this one. When we are launching EC2 instances, let's say I'm selecting the first one, and here it's the type. I'll go with the default one. Here in this step, we are selecting subnet. Basically, this is the availability zone, and by default, we are saying no preference, but Amazon is going to put your EC2 instance in one of these availability zones. And we cannot have an EC2 instance in multiple subnets or multiple availability zones. As you can see here, we have to select one of them. And this makes the same idea that when you are creating an EC2 instance, if I go to the next step, then Amazon is going to create an EBS volume for this EC2 instance, and that EBS volume is also on the same subnet or in the same availability zones. So going back to the slides, your EBS volume, like your EC2 instance, is just in a single availability zone. So that's the main difference between EFS and EBS volumes. In terms of the access for the EFS, up to thousands of Amazon EC2 instances can access from multiple availability zones and can connect concurrently to a file system. But for the EBS, a single EC2 instance in a single availability zone can connect to a file system. So you can see the big difference here. So use cases is big data analytics, as we said, media processing workflows, content management, web serving, and home directories for the EFS. And what this one is mostly boot volumes, right? So we are using EBS volumes for boot volumes, transactional and NoSQL databases, and data warehousing and ETL. Another thing that I would like to talk is whenever we are creating EFS in the AWS, we have to deal with something called EFS performance mode, which we have two performance modes. One of them is general purpose and the other one is max IO. So general purpose one is the default one, and for most of the file systems, we are going to use this one. It's ideal for latency sensitive use cases, and this is the normal one, and most of the time we use this. Another one is max IO, which is optimized for tens, hundreds, or thousands of EC2 instances access, and it's high level of throughput and operations per second. We have a trade-off of slightly higher latencies here. So I would say most of the application we start using general purpose, but if you need really high throughput, then max IO is your friend. Another thing that we need to talk is EFS throughput mode. Whenever we are configuring, we have two throughput modes. One of them is bursting, another one is provision. So the idea here is with the bursting, your throughput on EFS scales as the size of your file system in the standard class grows. Let's say you have 100 gigabyte worth of data, then your throughput is different than when you have 1 terabyte of data. When your data is growing, then your throughput is also increasing inside the AWS. This is something that the AWS is going to manage for you. There is a chart inside the AWS documentation that you can take a look, but basically this is like pay as you go. You have more data now and you can have more throughput. The other one, the provision one, is you are going to say, I need this throughput. So you can instantly provision the throughput of your file system independent of the amount of data stored. So we don't care if you have 100 gigabyte of data or 1 terabyte of data. We just need this amount of throughput. You can change it. You can change back and forth between bursting and provision, and you can even change your provisioned throughput to other numbers. But there is a 24 hours period that you have to wait for these changes. So in terms of the pricing, there is a link here, awsamazon.com/EFS/pricing. You can take a look, but basically price depends on your regions. And as I said, we don't have EFS for all the regions, and we can check inside the console. But look at the prices here for standard storage, infrequent access storage, and there's requests and throughput. And these are the prices. This is basically 3 cents per gigabyte per month. And we have these numbers here, right? So if I go and compare this one with the EBS, here for the EBS, for example, in the US West Oregon region, we have just 1 cent per gigabyte for provision storage for the SSD, for the general purpose one. So basically EFS is an expensive solution. If you can see that it is 3 times more when you're comparing it with the general purpose SSD and the EBS volumes. Bear in mind that EFS is not a cheap solution. You have to pay 3 times more when you are creating EFS volumes. With this idea, I just want to talk about pets versus cattle. And in traditional IT environments, usually we deal with our servers as pets. So this is going to be like servers or server pairs that are treated as indispensable or unique systems that can never be down. And in traditional systems, even I'm sure that right now you can see some of the pets in your environment, and typically they're manually built, managed, and hand fit. An example is mainframe or different servers, load balancers, firewalls, or anything that is master, slave, or active passive systems. So we deal with them like pets. I would say this could be a good idea if you have something like this. If you have a database server with 2 EC2 instances, maybe you can use EFS for sharing your data between these 2 servers. But the other one is the cattle one. And in cattle environment, we have arrays of more than 2 servers that are built using automated tools and are designed for failure, where no 1, 2, or even 3 servers are irreplaceable. So typically during failure events, no human intervention is required, as the array exhibit attributes of routing around failures by restarting failed servers or replicating data through strategies like triple replications or erasure coding. Examples including web servers as multi-master data stores such as Cassandra clusters, multiple racks of gear put together in a cluster, or just about anything that is load balanced and multi-master. So I would say it depends on your scenario, but if you have pets, then EFS could be a good idea. But if you have cattle, it means your EC2 instances, for example, they can just go away and you can build a new one from scratch with automated tools, and you can replicate the data at that moment. So you have to pay more for the EFS, then you can use the EBS volumes and EC2 instances and use something like an automation tools for figuring out how you can rebuild your environment. I have pictures to show you. So this is one of them, and you can see in the picture here that we have the EFS volume or file system here, and inside our AWS environment we have EC2 instances, or we have containers, or whatever compute that we have here, and we can use this EC2 instances and we can mount these volumes to multiple EC2 instances. Basically, let's say I have a data here, both of these containers or EC2 instances, they can see them. Another one is this one. Basically, you can have EC2 instances from different subnets or different availability zones, and they can see the EFS file system. So this is going to be shared between multiple machines. It's like a disk share between different machines, and they all can see this EFS volume. So if you work with the storage systems like EMC, Dell, NetApp systems, HDS systems, they usually support NAS systems, and you can create NFS volumes and you can mount it to different Linux systems. So this is the same idea, but it's a little bit expensive, and you have to just take a look at the price carefully. So let's go to the lab and start working in AWS console and configuring EFS inside the AWS. Okay, I am inside AWS Management Console, so go ahead into the storage category and click on EFS. Because this is the first time I'm using this, it says just create the file system, and there's nothing here. And EFS is stand for Amazon Elastic File System. I'm going to create this file system. We need to select our VPC. Right now we just have the default VPC. We'll talk later about creating multiple VPCs and start managing them, but basically it's per VPC, right? So we need a VPC here. So the default VPC is this one. Because I'm in the North Virginia right now, I have 6 availability zones or subnets. And you can see each availability zone is mapped to a subnet. If I click here, you can clearly see that we don't have the EFS in Asia Pacific, Mumbai, and Central Canada, Paris, Stockholm, and South America. So I'm going to change my region to US West Oregon. Give it a couple of seconds and you can see now I have less availability zones. So it's completely different between different regions. So let's keep this in the Oregon for now. Basically, we're just saying we need EFS file system, and you can deselect these availability zones. You can have it just across one zone. But the best practice is distribute it across multiple availability zones. So if you remember in the previous picture here, so when you're creating the EFS file system, this is all IP based. So it means, let's say we want to configure this EC2 instance here. So let me select the pointer. So on this EC2 instance, it has an IP address, and it should be able to see this EFS file system over the IP network. So you should be able to resolve, if you're using DNS name, you should be able to resolve the name to IP address of this interface here. So it's basically IP to IP communications on NFS protocol. So this is the target IP address from the EC2 instance perspective. Inside the console, we are selecting the subnets, and we're saying we need these IP addresses here on the EFS file system to be assigned by DHCP or automatically. So let's go back to the console. So these IP addresses, basically they are EFS IP addresses. These are the shared storage IP addresses. Another thing to take a look is there's a security group assigned to each of these interfaces that we are using for EFS. And we need to check this security group. So let's go and check it right now. I'm going to click on services up here. I'm going to select EC2. I'm opening it in a new tab. And here in EC2 Management Console, I'm going to select security groups. So I have a bunch of security groups, but the one that we are using for the EFS is this default one. If I click here, look at the inbound rule. It says all traffic, all protocol from all port range. The source is just the security group itself. So basically it's not allowing the NFS protocol by default. The outbound one is allow for any destination, which is wide open, but inbound is not wide open. So we need to configure this one later. So we'll take a look at this one, and we actually give it a try to see if we can hit the target NFS volume. And if it doesn't work, we need to configure something here or open it widely. So let's go back to the file system. So here, so everything seems okay right now. We just stick with the default settings. I click next step. Here I can give it a name for the tags. For example, I put the div just EFS-test, and environment, for example, is dev. So these are the things that I talk during this slide. So choose performance mode, general purpose, and max IO. We stick with the general purpose, which is the normal one. If you have really high throughput, then we're going to use max IO. And another one is throughput mode, bursting and provision. This is gonna increase throughput as we are using more data, and this is going to be a specific number that we can assign for throughput. So I stick with the bursting. So I talk about encryption also in the slide. This is going to be an encryption at rest, so it's going to be a disk layer, and there's a lifecycle management that we can move data between the storage class and the infrequent access one. So I don't select these two, and I'm going to click on next step. So basically this is a review. We are going to create EFS file system or an NFS shared volume that it is accessible through all of these availability zones or subnets through some IP addresses, and we'll see the IP addresses, and we are going to assign these security groups to them, which is not really open right now. It's not inbound rules are not configured. So the tags are here, and performance mode is general purpose, throughput mode is bursting, no encryption, and lifecycle policies. So let's create the file system. This is going to take some time, although I'm seeing success here, but if you scroll down here, the target state is creating. So this is going to take some time. Meanwhile, I'm going to create 2 EC2 instances in order to test this NFS or EFS file system from those servers. So I'm going back to EC2 dashboard. Okay, this was too much. I'm going to finish part 1 here, and I'll see you in part 2.